Mpirical provide compelling, interactive learning across a range of delivery options. Live on site, live online, or online anytime, we have a training course that is ideal for you. For a no-obligations chat about your training requirements, contact us at mpirical.com.
There are many different technologies which are being discussed in terms of the overall IoT landscape. EC-GSM IoT is simply one of them. However, in this video, we're going to focus on the key fundamentals of this technology in terms of the benefits which it can provide. Now, before we look at these, we're often asked, why are we dealing with a second generation technology for something as current as IoT? Why not use our third generation, fourth generation, or even the emerging fifth generation networks? Well, the answer to that question really is seen here. The GSM, even though it's a second generation technology, still covers 90% of the world's population, far greater than our third, fourth and potential fifth generation networks. So to begin with, we have a technology which has the greatest widespread coverage. With this in mind, the 3GPP, the Third Generation Partnership Project, set about updating the second generation technology. And therefore they did it by making modifications in the Release 13 specifications. This is particularly important for those of you wishing to go into a little bit more detail after finishing this particular course. These are the particular specifications you should turn your attention to, Release 13 and beyond. So let's just take a look at the benefits of EC-GSM IoT. But we'll also find other technologies which are also capable of supporting these sort of requirements. Be that improved coverage, reduced energy consumption, reusing existing infrastructure, thereby saving cost, supporting massive IoT, dealing with many millions of devices, and finally the requirement for enhanced security. So we'll look at each one of these in turn and see how EC-GSM is capable to support it. So the first thing that we're going to look at is improved coverage. What we need to do is make sure that our devices, our sensors, are able to communicate with the network. These often operating in very inhospitable environments. What we can see on the diagram then is our base station with a typical coverage area. But now we're introducing the concept of what's referred to as coverage classes, here CC1 or coverage class 1, supporting data rates fairly typical of GPRS for a given time slot, ranging from 8.8 kilobits per second upwards, depending upon the modulation and coding scheme that's been applied. In other words, if we have a very high quality radio link, then we can drive the data rates high. But given that our IoT devices may be operating in very poor radio environments, it's important that we can also support them as well. And this is where the other coverage classes come into place. Coverage class 2, 3 and 4, enabling us to increase the coverage. Now, what's important to stress here that we're not just talking about distance away from a base station. What we're talking about is operating in more hostile environments, potentially making the signal penetrate deep into a building, underground, or as well as rural locations. And we'll see this that our 4 coverage classes allows us to achieve a gain of up to 20 dB. What does this really make in real terms? Well, fundamentally up to about a 7 times improvement in cell coverage. But I should stress here, we're not simply talking about distance away from the base station. We've got better options here for the signal to pass into more hostile environments, enabling our devices to operate on very, very weak GSM signals. So, what does this really mean? Well, here we really need to turn our attention to the different verticals which EC-GSM is targeting. Things like utilities, where gas meters, electricity meters may be in very hostile environments, deep in the basement of a building, or again in very extreme rural locations. Again, extending the coverage is a key and often important requirement. Likewise, we could be dealing with things like manufacturing. Here we have our shipping containers, which may be being moved around the world. Again, could be in any location. It's important here that the sensors, which may be measuring temperature, for example, can keep communicating with the network. But the same holds true to many other verticals. Automotive, again ranging from cities out to rural locations. Retail, again operating deep inside buildings. We have smart cities where we can control buses, etc., etc. And finally, things like healthcare, again, monitoring our health, things like blood pressure, blood glucose levels, etc. The second method that we need to look at is the requirement for reduced energy consumption. And this again is often really down to the fact that these devices and these sensors will be operating in often very inhospitable regions. In other words, they're not likely to be connected to a mains power supply and therefore will need to operate using a battery. With this in mind then, we need to come up with new methodologies which are going to reduce the drain on that battery. We simply can't just keep adding bigger and bigger batteries. Now, one of the time frames we're looking at within an IoT deployment are batteries which can last to 10 years. It may not be a case of even being able to swap the battery for cost or logistic reasons. In the case of EC-GSM IoT then, we've made a number of changes. Here we can see one of them is actually reducing the complexity of the actual device itself. If this is a sensor in a rural location, the chances are it's not going to move and it doesn't need to keep monitoring the network with the same degree of frequency. Therefore, we can relax some of these particular procedures that it needs to engage in. Another method then is to allow the device to enter power save mode. What this means is the device can fundamentally go to sleep for very long periods of time, effectively switch off. However, it will remain connected to the network such that when the device reconnects and comes out of the deep sleep mode, it's able to start transmitting and receiving data. Here, we can actually get our deep sleep to move into durations of approximately 413 days. Although typically, depending upon the particular data we're sending, the environment or the vertical we're operating in, we may find that it wakes or sleeps for days, weeks, months, etc. And finally, the third method of doing it uses a process called extended DRX, discontinuous reception. Again, it just simply allows the device to go to sleep for periods of time and therefore save the battery. In this case, only sleeping for a maximum of 52 minutes. But this has an advantage over power save mode, is that when the device wakes again, it doesn't need to communicate with the network, which it does in the case of power save mode. Another benefit now is the ability it can reuse existing infrastructure. So in the case of our second generation networks, again we can see it here on the diagram, for most vendors to now support EC-GSM IoT, it's simply just a case of upgrading the software down at the base stations and the base station controllers. Obviously, in terms of the devices, these will need to be new. But the chances are these radios now with their embedded SIMs may be built deep inside other forms of equipment, meters, sensors, cars, etc., etc. Whilst we're also looking at reusing existing infrastructure, it's also to consider our radio spectrum as a very valuable commodity for the service provider. And therefore, we need to use this as efficiently as possible. So here on the diagram, we can see where our EC-GSM IoT can operate. Clearly within the existing frequency bands for GSM and GPRS, be that 800, 900 megahertz, 1800, 1900 megahertz. But also up at 2100 megahertz, which is typically used by our third generation UMTS and fourth generation LTE networks, we can now also operate our GSM IoT here within the guard bands. These are elements of radio spectrum which are used to protect and prevent interference between neighbouring channels. Again, there is enough room here for us to actually also carry out communication. Now, interestingly, a work study by the 3GPP suggested that it's actually possible to provide national coverage with only 600 kilohertz of radio spectrum, using a 3-frequency repeat pattern, as we can see on the diagram. Remember, our GSM GPS channels are always 200 kilohertz. So here we've simply got one frequency sitting in each sector of the cell, so a very tight reuse. This, at first glance, may not look terribly effective. However, if we consider the actual data that these sensors will send, will be typically small, particularly when we compare it to things like smartphones. Again, a device simply monitoring water levels will only need to send a very small amount of data, and this data in terms of frequency may only need to be sent weekly, daily, or possibly as a flood alarm. Therefore, even using such narrow frequencies, it's still possible to support many thousands of devices. Again, this clearly depends upon the volume of data that these devices or mobiles need to send. The fourth benefit then, here we can see support for massive IoT, and this really comes up to these thousands of devices which people are predicting we will move into in the coming years. Now here we can see we have a report from Ericsson in terms of predictions moving forward up to 2022. Not just looking at our IoT devices, but really moving across the whole gambit of communication systems. Devices here with an IP protocol stack able to communicate. So to begin with, we have our good old traditional fixed telephones, and we can see over the time period that these numbers are beginning to drop off, not surprisingly. For our mobile phones, again fairly consistent over the time period, again ending here at 8.6 billion devices. Again, this is still more devices than there are humans on the planet. Likewise, our PCs, our laptops, our tablets again show a slight gain over the period. But it's only now when we move into our short-range IoT devices that we start to see substantial growth. We must stress, however, our short-range IoT devices are not based on EC-GSM IoT. This is a wide-range IoT network. Our short-range are going to be using technologies such as Wi-Fi, Bluetooth, Zigbee and Z-Wave, covering very short distances of a matter of a number of meters. It's only when we move into the wide area IoT that we're going to see our EC-GSM IoT technology, part of the 3GPP family. But it's also worth pointing out that there are other technologies here based on fourth generation technology, LTE-M for machines and also narrowband IoT. But bearing in mind, we also have proprietary systems as well covering this wide area, such as things like Sigfox and LoRa. So the final thing we need to look at then is the requirement for enhanced security. Now we must recall that our GSM GPRS technology was actually invented back in the latter part of the 1980s, and this includes the security as well. Well, clearly the threat landscape has changed substantially over that period, and therefore it's necessary to make enhancements to this technology so it's able to operate in the current environment. There's been many examples of very weak IoT devices with very poor security, which have been taken over by botnets and used for distributed denial of attacks. So in terms of the changes, particularly for EC-GSM IoT, we can see now that we're actually supporting both encryption and integrity protection. We're using the security associated with our 3G and our 4G networks, which builds in mutual authentication and also prevents things like bidding down attacks. Here we can see based on UMTS, aka our authentication and key agreement, making the systems robust for the 21st century networks. So that's it, the key benefits then of our EC-GSM IoT technology. Here we can see really looking at improved coverage, reducing our energy consumption, giving us our battery lives of up to 10 years, reusing existing infrastructure to reduce costs. Remember, as far as our service providers are concerned, we can introduce this technology fundamentally through software upgrades. Support for massive IoT, provided that the devices are really sending very small amounts of data infrequently. And finally, we need to make sure that these networks are secure, such that our information is protected as it passes across the network. Now, the rest of the videos in this module are really going to go into more detail in terms of the technical methodologies by how this is actually supported. And before looking at these videos, it may be advantageous to spend a little time looking at the actual air interface applied to GPRS and Edge.
Need to know more? Why not visit our store, where you can choose from over 200 hours of video-based training. Alternatively, you can contact us to discuss any specific training requirements you may have.